This is a spec for the solving for a variable module. Let me make that a little bit thinner. Solving for a variable. And the whole goal of this will be a pretty straightforward module where we'll give the students an equation, or well, really an equation, and in terms of one of the variables, and they need to solve for the other one, or one of the other ones. So we might say something like solve for x, and maybe we'll give them y is equal to zx plus 3. And so when the student clicks hint, we'll just give them the steps. And you might want to use the code from the level 1 or 2 or 3 linear equations, or you might just want to write your own and just do a bunch of different cases. That's probably actually the latter is probably the easier way to implement this. So the first step, you'd say, subtract 3 from both sides. And it would be y minus 3 is equal to zx. And then you'd say divide both sides by z. And so you'll get y minus 3 over z is equal to x. And so the choices here, you'll have your correct choice. X is equal to y minus z over 3. But then we'll have some incorrect choices. Maybe one where you just swap the x and the y. So you get x is equal to zy plus 3. Maybe you have one where you have solved for well, maybe we could switch it up a little bit. Maybe you have x is equal to, maybe you make up some random things here, 3y minus 3z. You could have x is equal to, I don't know, y plus z minus 3, just random combinations of all of this stuff. And then you have x is equal to 3 over y minus z, maybe the inverse of that. So just be creative in the choices. So that would be one type of problem. And it could be solve for z instead, or you could have this exact same problem, but you could replace y, z, and x with a, b, and c, just so that there's some variety. And we can also give more involved problems. So it could be something like this. Let me clear this out. And so it could be more involved problems like solve for c. And we have a is equal to bc plus dc plus ac, and maybe plus 5. And so in this situation, the student should, or maybe they'll realize that you can undistribute the c, or you can factor out the c. So the first thing we could do, we could say subtract 5 from both sides. Subtract 5 from both sides. So you get a minus 5 is equal to bc plus dc plus ac. And then this is the same thing, or you could say factor out a c. Factor out a c. And this is a minus 5 is equal to c times b plus d plus a. And then you say divide both sides by b plus d plus a. So then you get a minus 5 over b plus d plus a is equal to c. And obviously you want to change these numbers. Maybe we have numeric coefficients here instead of just letters. And then the last type that we might want to do, or actually we probably want 4 or 5 types. And if you keep switching up the numbers and keep switching up the letters, it'll look like a lot more types. You could have something like this, where it's not just a straightforward a polynomial expression, where it could be something like, let me write it. So solve for y, and maybe you have something like x y z is equal to I don't know, let's make it is equal to 5. And so in this situation, actually, let me make it a little better. Let's say x is equal to y, z. Well, actually, this isn't any different than anything we've done before. But you might want to do it where it's not explicitly solved for anything. So maybe you have x, y, z plus 20 x, y plus y is equal to, and we want it to be linear in terms of y. Otherwise, we don't want to deal with square roots or quadratics or anything just yet. Maybe that's equal to 5. And of course, the hints here, you factor the y out. Y times xz plus 20x plus 1 is equal to 5. Divide both sides. Y is equal to 5 over xz plus 20x plus 1. So be creative. The whole point here is to make students comfortable with the algebraic manipulation and being able to solve for one of the variables in terms of other variables, so it stays relatively abstract.